Good day. My name is KATRINA LOMOTAN, and my thesis partner is Alejandro III R. JEREZ with our advisor, Engineer Analyn and Yumang, and today we will present our thesis entitled Non-invasive uric acid meter using spectrophotometry for the 37th EECE thesis colloquium on the third quarter of the school year 2019 to 2020. So for the introduction, spectrophotometry is a method to use how much a chemical substance absorbs light by measuring the intensity of light as a beam of light passes through a sample solution. So basically, the spectrophotometer works by passing a known measurement of light beam through a sample to measure the light intensity of that sample. Also, a spectrophotometer is made up of two instruments, a spectrometer and a photometer. The spectrophotometer is designed in a way that the liquid or a sample is placed between the spectrometer and the photometer. The photometer measures the amount of light that passes through the sample and delivers a voltage signal to the display. If the absorbing of the light changes, the voltage signal also changes. The basic principle is that each compound absorbs or transmits light over a certain range of wavelength. So, for the statement of the problem, currently, the ways of determining the concentration of uric acid in the blood is by blood extraction. Through blood testing, blood is extracted invasively and can determine the uric acid levels, but is done invasively. Another way of detection of uric acid crystals are the extractions of synovial fluid from the joints, thus is done invasively as well. This is done by extracting a sample of the synovial fluid, which is a thick liquid that lubricates the joint and allows for ease of movement. In joint diseases like arthritis, the synovium of the joint is the main place where the inflammation occurs. So for the conventional method, there is blood testing, which requires an invasive method of determining the uric acid levels through blood extraction and also through urinalysis, and also with the use of a uric acid meter. The results of the blood extraction takes time to obtain and costly as well, and as well as the urinalysis. On the other hand, the uric acid meter gives an instant result but is done invasively as well. So for the main objectives, to implement a non-invasive use of spectrophotometry in detection and measuring urate crystals in the blood. For the secondary objectives, to convert the wavelengths into milligrams per deciliter, wherein this is the measurement of the amount of a particular substance in the blood. Also, to use a linear regression to obtain the ideal equation to obtain the uric acid level. And lastly, display the results in the LCD display screen and determining whether the person has either high, normal, or low level of urate crystals in their blood. So, for the scope, the device will be focused on detection and measurement of uric acid crystals in the blood, meaning the device will concentrate on determining the uric acid levels non-invasively by putting the spectrophotometer against the wrist, here wherein it should be on top of visible vein as well. The device will also display if the person has either low, high, or normal uric acid levels. For the delimitation, the testing was done on 20 males or females of age range between 18 to 24 years old and without any prevalent diseases, which can bring about high uric acid levels like diabetes and such. For the significance of the study, there will be another option on measuring the uric acid levels in the blood. More significantly, this is also a non-invasive method of determining the uric acid levels in the blood. So for the methodology, first is the determination of the problem. Together with it is the review of related literature and also doing research on the current methods used in determining the uric acid levels in the blood. And from this, the researchers will be able to have objectives based on the problem statement. The proposed solution is the use of spectrophotometry and as well as designing a non-invasive uric acid measuring tool. For the hardware and software development, this will be done in conjunction with testing and calibration until such time that the desired outputs have been obtained. After the desired outputs have been obtained, the statistical testing and conclusion will be done for the device. For the conceptual framework, the input will be the reflected light on the wrist, and it will be processed by the device by converting the light intensity measurement to uric acid measurement, and the output will be the uric acid level in the blood. in milligrams per deciliter. For the block diagram, the microcontroller, which is the Raspberry Pi, will process all the calculations from the data obtained by the spectrophotometer, and this will be outputted on the LCD screen. And all of these components will be connected to a power supply. In Figure 3.5, for the flowchart, first the program will ask the gender of the user, and after this, the spectrophotometer will output a light in 860 nanometers of light, and it will go to the module wherein the uric acid will be classified, and the output will be the uric acid level and its classification on the LCD. So this flowchart basically explains that for males, the normal uric acid is 3.4 to 7 milligrams per deciliter, and for females is 2.4 to 6 milligrams per deciliter. Values which are higher than this for both genders will be considered high, while values lower than this, the values will be considered as low uric acid levels. So this is the device setup for the device, wherein in the left side is the spectral sensor, in the middle is the LCD screen, which can be used better with the stylus. So for the next slide, this is the actual testing of the device. From the Benechek uric acid meter, the sample measured 8.5 milligrams per deciliter, while the device had measured 8.82 milligrams per deciliter, yielding to a 3.6% difference. So for the equations, we use the Beer-Lambert law equation, wherein A is equals to epsilon multiplied by L multiplied by C, wherein A is the absorbance of the material, epsilon is the molar absorbability in liters over mole multiplied by centimeter, L is the path length in centimeter, and C is the concentration of the solution in moles over liter. Absorbance is given by the equation A is equals to the logarithm of the incident light over the transmitted light. After a few tests, we will use the obtained molar absorbability of the uric acid for the direct conversion of the measurements of the spectrophotometer into uric acid measurements in milligrams per deciliter with the equation below, C equals to A over epsilon multiplied by the path length. So for the data presentation, this is the table for the concentration compared to the light absorbed, wherein the light absorbed is obtained by the sensor, whilst the uric acid concentration was obtained from the Benechek uric acid meter. For the next table, this is the table for comparison and calibration of the device, wherein we had taken the data from the uric acid test kit measurement, which is the Benechek uric acid meter, and from the device measurement, and the next column is the percent difference of the two. So this is the scatter plot of the device, wherein the formula to compute the concentration of uric acid levels in the blood non-invasively was formed. The dots seem to be far from the line, but the reason is that the concentration levels is from 1 up to 11 only for the gathered data. Table 3.3 is the confusion matrix of the study, wherein there was one misclassification. So for the conclusion, the purpose of this study is to implement a non-invasive use of spectrophotometry in detection and measuring of urate crystals in the blood. The device had an accuracy of 90%, misclassification rate of 10%, and an average percent difference of 6.12% compared to the Benechek uric acid meter. The results of the study is that the proposed uric acid measurement was with compatible accuracy compared to the invasive method of extracting blood and using uric acid test strips together with the Benechek uric acid meter, which is a very useful tool for measuring and monitoring the uric acid level in the blood. The researchers therefore conclude that they were able to develop a device using spectrophotometry as a non-invasive method of determining uric acid levels in the blood. For the recommendation, the researchers recommend to further improve the device by improving the accuracy in a way that there should be more measurements of the light intensities measured within the wavelengths of the device, which is in the near-infrared. Also, the researchers recommend trying other wavelengths for the measurement of the uric acid, especially in the infrared light region. So for the references, picture of blood test from newatlas.com, picture of urinalysis from ucsfhealth.org, picture of uric acid meter from aliexpress.com. That would be all. Thank you.